The inheritance and multiple inheritance mechanisms that we have seen, in particular redefinition and renaming, make it possible to have a really flexible approach to combining classes. We're going to see some of these techniques, and that will also give us the opportunity to see the last one of these mechanisms, undefinition. The key rule to remember is, once again, this rule of a mapping between names and features, specifically feature names and features, which is really the key to keeping things simple. So one thing that we can do is what is known as feature merging. Here, the rule is the one that I mentioned in the last lecture, which is that a name clash is okay if at most one of the clashing features is effective and all the others are deferred. So let's assume here that we have D, which inherits from A, B, and C, and all of these classes have a feature called F. We also have to assume that the signatures are the same, that is to say, they have the same number and types of arguments, otherwise we would really have a clash that we cannot reconcile. But what's important is that two of them, those from A and from B, are deferred, and the one from C is effective. So in that case we have a name clash, but it's not a bad name clash, because what we really have to do is to reconcile the various features, and there's no problem in doing this, because we only have one implementation, one effective version. A name clash is a problem if we have conflicting implementations, in which case, of course, we would have to choose between them, but here there's no particular need to choose since we only have one implementation. So this is known as feature merging, and the effect is going to be very simple. It simply means that in D we have an inherited feature F whose implementation is the one that comes from C. So they all get subsumed, so to speak, into the F from C. And the F from A and the F from B just disappear, or rather they're absorbed into the F from C. Now, what if you want to merge some features from different classes, two of which, or n-1 of which, are deferred and one is effective, but they don't have the same name? Well, in that case you cheat. That is to say, you are going to use renaming not as we did before to remove a name clash, but in fact to introduce a name clash, which will be immediately resolved because only one of the clashing features is effective. So in a case like this, we are going, when inheriting from A, to rename G as F. This little squiggle here means rename. When we inherit from B, actually in this case we keep the name, and when we inherit from C, we rename H into F. So you see what we're doing here? We want the implementation from C, but we want the name from B, F. We could of course have chosen any other convention, but that is our goal here. We would like all the features to be merged into one. We would like the implementation to be that of C, which is H in C, but we would like the name to be the name F from B. So we are going to rename two of them, G into F and H into F, and we are going to, as a result, have three features called F in D, but two of them are deferred, so they're all merged. In this case, we force a merge. Let me show you the actual class text on the left. Class D inherits A. In A, we rename G as F. Remember that we always need the end keyword for such clauses. Then B, in this case, for B we say nothing because we just don't have any renaming or redefinition or anything else to do. And in C, we rename H as F. And then the compiler is going to accept this class text because even though it sees a name clash, actually a double name clash since we have three features called F now, it sees that two of those, the one coming from A renamed from G to F and the one coming from B under its original name F, are deferred, and only one, the one coming from C where it had the name H is effective, so all is well that ends well, and all these features live together happily ever after under the name F and the implementation from C. What if we want to merge a few features, however, we are not in the happy case in which two of them were deferred, or n-1 of them were deferred, and only one of them was effective. Let's assume, for example, that we have three of them that are effective. To make things simpler, I'm assuming that they all have the same name, but of course, if they had different names, we could use the previous trick of renaming to force them to have the same name, in other words, to create a name clash. Here we already have the name clash, and if we don't do anything, then, as we have already seen, this is a bad name clash, and the class D would be invalid, illegal. However, we can still merge them if we want to, if we accept that there's room for at most one implementation. Of course, we cannot keep all three implementations, the implementation from A, from B, and from C. We have to choose one of them. If we want to keep all of them, we can, of course, but then we have to give them different names. We could rename F from A as G, F from B as H, and, for example, keep the name from C. But that's not what we are looking at here. Here we are actually happy to sacrifice, so to speak, two of the implementations, for example, the ones from A and B, but we want to keep one of the implementations, in this case the one from C. So this would have been possible if the first and the second F, the ones from A and B, had been deferred. Well, that's the solution. Make them deferred again. This is known as undefinition. In my diagrams here, it's shown as a minus minus in the same way that redefinition is shown as a plus plus. So what we're going to do is that we're going to forget the implementation of F from A, we are going to forget the implementation of F from B, and we are going to merge all three of them into a single feature at the level of class D, whose implementation is the implementation of the F from C. And this is what undefinition does for us. Here is the syntax. It's the same as before. It's one further clause together with rename and redefine. So you can have class T, which inherits from S and undefines V. So in this particular example, here's the way the class will look like. Class D inherits from A undefines F, or rather D undefines F from A, B nothing to do, and C undefined F, and that's it. The trick succeeds, and we merge F from A, F from B, and F from C into one feature whose name is the common name F and whose implementation comes from C. So we have, so to speak, vanquished the implementation from E and the implementation from B, and the implementation from C has triumphed, overtaking both of them. With different names, well, we achieve the same aim by simply forcing an artificial name clash. So let's assume that we have F from A, G from B, and H from C that we all want to merge, and we want to keep the name F, so that's the name that comes from A, and we want to keep the implementation from H, that is to say from the version in C. So it is straightforward. The main advantage of this particular example is to show you the complete syntax with kind of all the clauses except redefine combined. So class D inherits A with undefinition of F but no renaming. Then it inherits from B and it renames G as F in order to force the name clash, but it kind of removes the name clash immediately by turning it into a harmless name clash. In other words, making F immediately defer. That's what undefined does. And same thing for C. It renames H as F, but it does not undefine F. So this implementation will remain, and we are okay because we have three features of name F, but only one of them the one from C is effective, the other two are deferred. This also enables us to see a bit more precisely when a name clash is acceptable. We still have the case of repeated inheritance coming in the last segment, but with what we have seen so far, a name clash is acceptable if all features have compatible signatures and at most one of them is effective. So the point about signatures, I mentioned it before, but it's worth repeating. In order to be able to merge different features, of course, they must have the same signatures, meaning that they must have the same number of arguments and they must have the same types for these arguments. And then at most one of them can have an implementation, and in that case, that implementation imposes its implementation, it subsumes all the others. Now, let's assume that we want to take effective features and do this. Well, here, this is the same case as before, but let's see what we can do. We can do a1.g, we can do b1.f, we can do c1.h, and we can do d1.f. Let's assume that through polymorphism, all these variables, a1, b1, c1, and d1, denote the same object, are attached to the same object. So we have done something like a1 receives d1, which of course is possible thanks to the law of polymorphisms. b1 also assigned d1. C1 also assigned a value of D1. And so, in that case, A1.G, B1.F, C1.H, and D1.F, through the magic of polymorphism and dynamic binding, will have exactly the same effect. What we've seen in this segment is a set of games: renaming, redefinition, undefinition, merging. The first three are language mechanisms. Renaming and redefinition had been seen before, undefinition is new. Merging is a consequence of using these language mechanisms. We've seen a set of games that we can play with features and their names, and you can see that these mechanisms give the machine builder, the class builder, we can consider a class builder as someone who is building a little machine. They give him or her a lot of flexibility in building the machine by combining existing machines, by combining existing classes, and playing with the features, their names, their implementation through renaming, redefinition, undefinition, and merging. This is mostly useful for writing reusable libraries. It serves in ordinary application programming as well, but it becomes really interesting if you want to build libraries for which you're looking at some form of minimal design, as simple and as elegant as possible, with exactly the right names. And the key rule remains the mapping between feature names and features. For one name, you are going always to have at most one feature.